In today's video, we are going to do some overclocking to the mighty IBM PS2 model 95XP. We have already done some overclocking in a previous video, but we have only gained about 30%, and that just isn't enough, is it? Let's start with a quick test and just make sure the machine works. It's been a few weeks since I turned it on. Okay, it's slowly going through all the checkpoints and showing us what it's doing on a nifty display. Hard drive spun up, it's counting up the RAM, and the machine boots. Okay, so the 95 is still working. The CPU in this machine is not installed on the motherboard. Instead, it's a separate card called the CPU complex that can be removed and replaced. In our previous attempts, we have used these Type 2 boards. This one came with an SX25, and this board came with a DX2. And the fastest we have been able to go with these cards is to use the DX2 ODPR66, running at 50 MHz. We are actually going to get back to these cards in a future video and see if we can make them go faster in a different machine, because I think this is some kind of weird compatibility issue. Unfortunately, that machine is still not restored, so let's put these aside and then we'll try some more in a future video. And today we're going to play with this monster card. This is a Type 3 complex. It's a dual PCB contraption. Really beefy card. There was only one version of the Type 3 complex, and they all came with a DX50, not a DX250. So this CPU doesn't have a clock multiplier, it's actually running at 50 MHz. So this CPU should be a bit faster than the ODPR running at 50 MHz with a clock multiplier. Another feature of this card is that it has 256K of level 2 cache, so that should increase the speed even more. Before we can test the card, we actually need to make a minor repair, because one of the standoffs is broken, so we need to fix it. That may not seem like an important thing, but this card is hanging upside down in the machine, and the second PCB is really heavy. I'm not sure if you can see it on camera, but it's actually bent out quite a bit if we install it like this. Luckily, this is a very easy fix. I found a suitable standoff in my standoff kit, and then we'll just install it with 2 screws. And hopefully this is the only repair we have to do today. I've had quite a lot of repairs lately, so I don't mind a break and just enjoy some overclocking and restorations. Okay, let's install the card and see if it works. The standoff is actually slightly too long, so I'll probably replace it again later. Okay, let's turn the machine on. Okay, we're getting checkpoints on the display. That's a good sign. And we've got a cursor on the display. Hard drive spins up, and it's trying to read from the diskette drive, because we've got an IML error. That is expected, because we have replaced the CPU complex. So these machines use different reference disks, depending on what CPU complex you use. So to install that complex, we need to use the Type 3 reference disk. Insert in a diskette drive, and reboot the machine. Okay, we still have the error, but now it continues and reads the reference disk. Okay, and it seems to be working. Processor board error, as we expected. Automatic configuration is being run. Automatic configuration complete. And the machine reboots. It's counting up the RAM. This machine, by the way, has 32 megs, 70 nanosecond parity. And with this complex installed, we can actually go up to 64. But I think it's a bit of an overkill. Even if we are successful with overclocking, this is going to stay as a DOS and Windows 3.1 machine. So 32 megs is more than sufficient. Okay, so I'm not sure if we are done. We may have to restore the IML. Let's try to just reboot and see if it's done. No, it wasn't. So we need to restore the IML. So one quirky feature with these machines is that it stores the BIOS settings on the hard drive. So that's basically what we're fixing now. We need to store the drivers for this complex on the SCSI drive. Okay, we're back in here after reboot. Now we actually have an IML error. So let's hit enter, backup restore system programs, and restore the system partition. The system partition currently on the hard disk drive will be replaced. That's exactly what we want. And we are prompted to do reboots with the ref disk still in the drive. And it continues, copying data into the system partition. Remove the diskette from drive A and insert the diagnostic diskette. And I've got a copy here. All these diskettes are easily available at Ardent, and it's copying more data into the system partition. The restoration of the system partition is complete. Insert a ref disk. Okay, I think we're done in here. So let's back out and start the operating system without the ref disk. And the machine boots into DOS. So we're all good. This is a working complex. Awesome. Well, overclocking without benchmarks is no fun. So let's install the MCA-ID, because I have some benchmarks on here. These are awesome, but they are unfortunately still too pricey to keep in every project. So this card keeps moving around in different projects. Okay, so now we have access to the software on that SD card. And we can run some benchmarks. Let's see what score we get with the CPU complex without any changes. So with the SX25 we got 10.28 FPS. And with the DX266 running at 50 we got 13.9. This video is sponsored by PCBWay, for a very good reason, as you will see later in this video. Thank you PCBWay for supporting this channel. Well, I definitely think it's an improvement. Well, I can tell we're not gonna get an amazing score, but this is actually definitely playable already. Just at original speed. So we definitely have more than 13.9, but I'm gonna guess below 20. Okay, 18.26, so not a bad guess. So not quite 20 FPS. Well, 18.2 isn't bad, but we want more, don't we? So let's try out this loaner here. So this is a TrinityWorks power stacker. It lowers the voltage in the socket, so we could run a 5x86. The 5x86 is designed to run at 133 MHz, but we have a 50 MHz crystal on the CPU complex. So we're gonna try it together with this CPU here. We have successfully overclocked it to 160 by running it at 4x40. As far as I know, this interposer is untested, and we have never tried to run this at 3x50. So the only way to find out if this works is to just test it. Not sure exactly how we're going to solve the cooling issue, if this actually works. But at least for now, let's go with this Cooler Master S7 GI15 4015. Not a big cooler, but I guess it will give us at least some cooling. We'll figure something out later. Okay, so it was actually quite easy to install, because it uses these clips. It slides on both sides, and that holds the cooler to the CPU. So for a quick test, this is perfect. And if this wasn't a thick contraption before, it definitely is now. Let's hope it even fits. Well, I guess it does, but barely. I think we have like about 2 millimeters between the fan and the power supply. Luckily the power supply isn't covering the entire fan here, but it does cover almost half of it. So not ideal, but for a quick test this shouldn't be a problem. I have a spare power connector from the power supply here. So now the fan should be powered. We also have a spare power connector we could use on the MCA-ID card. Okay, here goes. Okay, we've got checkpoints. That is a very good sign. That means it's at least executing some code. Hard drive spins up. We've got a cursor. It's counting up the RAM. Okay. Keep your fingers crossed. Come on, PS2. You can do this. Oh, and it boots! Holy cow, I think this is actually working. Wow, we're in DOS. Well, I guess we need to run some benchmarks. Okay, let's see if we can beat 18.2. Well, definitely playable. I was expecting it to be slightly faster. Yeah, I'm not sure about this. Maybe we are running at 100. But hey, definitely playable. And I'm pretty sure we're running faster than 20 FPS. Okay, let's see. 22.26. Okay, so definitely an improvement, but not what I was expecting. Let's try landmark system speed tests. We're running at 154 megahertz. So why are we not getting a faster score? Well, I guess it could be the video card. I haven't done much overclocking with the XGA2 card. So I'm thinking maybe this is our limitation here. And in here too it's reporting 150 megahertz. And the score is below 5x86 running at 133 megahertz. I don't really trust this benchmark because I think it's designed for much faster CPUs. And we've got 16K of level 1 cache and our 256 of level 2 cache. So everything seems okay, this is totally working. But I was expecting a better score. So I guess someone needs to reverse engineer a faster graphics card for the PS2 machine, because they are incredibly difficult to find. And even if you can find one, they are way too expensive. Well, this interposer is a loaner, and it's gonna have to go back to its owner. But thanks to the sponsor of this video, we've got some of these. This is Scrap Computing's awesome 486 socket blaster. It's an interposer designed to do basically the same thing as the Trinity power stacker. The power stacker, however, is difficult to find. But with these interposers, you can just order some PCBs from a PCB manufacturer like PCB AOYUE, and then just build them yourself. And I think they are about the same height. So I think we can use this cooler again. Okay, it fits with basically no margins whatsoever. It's almost touching the power supply. I think I can get a paper in between, but that's about it. So probably less than 1 millimeter. But again, it's only covering a part of the fan. So I think this is going to work, but it's definitely not ideal. So eventually we need to find a better solution for this. Okay, here it goes. Okay, we're getting checkpoints. We've got a cursor. Hard drive spins up. And it's counting up the RAM. Yes, it boots! Awesome! So the issue with this interposer is that it has a very small VRM, not really designed to run a 5x86 at 150 megahertz. But hey, apparently it works. Let's confirm that it's stable with some benchmarks. We should get roughly the same score as with a Trinity stacker. Oh no, it crashed. Oh crap. Yeah, this interposer unfortunately needs a better VRM. I think the original Trinity stacker is good for about 3 amps. But the socket blaster is running one of these tiny little modules. I think for most people that's not a big issue. But if you really want to push your system to 140 and 150 megahertz, that module unfortunately just isn't giving enough power. I have successfully run this interposer in many of my machines. Very stable at 133 MHz. So that seems to be the limit to how much power that module can deliver. Well, aside from being accessible, one big advantage with the socket blaster compared to the original Trinity part is that it has a jumper for 4x mode. So we need to get the crystal on the CPU complex in the socket. I'll start by adding some solder while the desoldering gun is heating up. Check out that crazy connector, by the way, between the two PCBs. That thing is insane. I'm not even gonna try to count all those pins. Well, since the VRM isn't giving us enough power to run at 150, there's no point in trying to go for 200 today. But what we can do is to lower the speed and try something between 100 and 150. I'll push some of the pins out from regular sockets, and then we can use it as a crystal socket instead. And all that's left to do now is to solder the socket to the board. Oh crap, apparently I ran out of 40 MHz crystals, so this unfortunately is a fail. Well, in that case, let's reinstall the original crystal and put our attention to the power issue we're having instead. Well, we have actually tried a couple of VRMs before, but the problem with these modules here is that the actual VRM chip is very often fake on these modules. So in the attempts we have done so far, the damn VRM just keeps crashing as soon as we push it to 140 or 150 MHz. The VRM on the boards we have tried before, they're all obsolete, so the only way to find them is on AliExpress and eBay. So we have no way of knowing if we buy an original part or a fake. But this module is different because it's using an LM2576, and that is not an obsolete part. So, in case it's a fake, I've got a brand new chip that I bought from Mauser. So this is guaranteed an original part. And this module, by the way, is good for 3 amps. Well, unless it's a fake chip, of course. Okay, so first we need to remove the VRM on the interposer. So as I mentioned before, this VRM is good up to about 133 MHz. But then it just crashes. And that is most likely a fake part too, because I bought these modules on AliExpress, or possibly eBay. Okay, so this is going to be sort of a prototype. So I'm going to make it as easy as possible on me. I chopped off a Molex cable in the middle and connected half of it on one side of the module and the other half to this side. So we should now have 12 volts in. Let's turn the machine on and check. We've got 12.2 volts in and apparently 12 volts out too. So let's turn it down to about 4 volts. The 5X86 runs off 3.45, but since we are overclocking, I think about 4 volts should be perfect. Yeah, let's give this a try. Okay, so the power module is now connected to the socket blaster. So we should now have 4 volts at the CPU. And we do. Okay, the whole contraption has been reassembled again. It's a bit of a mess, but we can always improve this, if this actually works. Yep, doesn't get more bodgy than this, but this should be good for a test. Okay, here goes. Oh crap, we've got a weird error. That's no good. Well, in that case, let's test this module on a generic board. So this is a SOYO 25L2. It already has a VRM on board. But I have set it to run at 5 volts with the jumpers, just so we can make this test. Here goes. Okay, posts. And it's reporting AM486DX4S, running at 200 MHz. I have set the jumper on the socket blaster to 4x mode, and it actually works. This board, by the way, is faulty, so it gives me a keyboard error. It doesn't matter what CPU I'm using, but it's actually not a fault, because the keyboard works. So we're gonna repair this board in another video. It has a couple of other issues too. Okay, so we know the module works. So that's good. Okay, so let's test again. And we immediately got that error. Well, we can't run any diagnostics if it doesn't read from the diskette. Well, I'm trying to cheer myself up here. So I'm gonna say this is not a total failure. We have actually managed to more than double the speed of the IBM PS2 95 XP. But this is all I had time for this week, and I'll see you guys again next week.